Okay, number 25. So we're going to try to find out the interval of convergence for this particular problem. So let's take a look. And the way we're going to do that is go to the whiteboard. Oops, I didn't mean to do that. And I'm going to the whiteboard, right? All right, what I'm going to do here is write down AN. And AN for this problem is going to be x to the n over n plus 1. And then I'm going to write down n plus 1 now. That's going to be x to the n plus 1 over n plus 1, n plus 2. And what I need to do, I'll do the limit momentarily, but I need to get the ratio an plus 1 over an. Relatively simple to do. We'll take the absolute value of it later. I was looking at the ratio at this point. So what do you get over here? X to the n plus 1, n plus 1, n plus 2. And instead of dividing, I'm going to multiply by the reciprocal. And the reciprocal here is going to be n plus 1 over x to the n. I'm going to simplify this, and this would give you x. And what happens? Well, the n plus 1 disappears, and you're left off with n over n plus 2. I'm going to write that a slightly bit differently. I write this as 1. I'm dividing by n, by the way, 2 over n. All right? So I'm going to do the ratio test now. That's the limit as n goes to infinity of an plus 1, the absolute value of it over an. Well, this can be the limit as n goes to infinity. I'm taking the absolute value of this thing over here, which is relatively simple to do, by the way. It's just going to be this over here. And I want that to be less than 1. Well, that's easy. Absolute value of x less than 1. That means x is between 1 and minus 1. Now, the problem for me now is I got to evaluate the endpoints to see what happens there. So, if you let x equal 1, let's see what you'd get. If x equals 1, what do you get? You get this series over here. And what do you get there? Infinity. And you get 1. And on the bottom, what do you get? You get n plus 1. Well, this is a convergence series. And by the way, you can use comparison test over there. It compares nicely to a p-series. Let's do x equals, I have to include that now. Let's do x equals minus 1. What do you get there? J equals 1 to infinity, minus 1 to the n plus 1. Well, this is also convergent. What I can do is just the absolute value of that. I get this over here. It's convergent. This is absolutely convergent there. Well, let me put this over here, and I got my interval. What's the interval going to be? Minus 1 to 1. Everywhere else it's divergent, by the way. Either answer is fine. All right? Thank you.